everyone. Good morning, good afternoon, or good evening. Welcome to Gautham IT Solutions. My name is Musab, and I'll your trainer in Gautham IT Solutions for Linux. Now, in this chapter, we are going to learn a very interesting concept called swap space management, one of the very critical thing to manage to keep your system running smooth and fine. Now, in this chapter, we are going to talk about what is swap space, what is the utilization of swap space, and the commands associated with swap space. Now, in order to understand the swap, first we have to understand what is the role of RAM. See, we maintain a component called RAM, random access memory, in Linux. What is the role of RAM? See, RAM is utilized to execute a process. Any process which you want to execute must be present in RAM. No process can be executed outside of RAM. So any process that you want to run, it must be present inside RAM. That's the role of RAM, right? Now, imagine that if the RAM is completely filled up, then what will happen? If you don't pay attention towards it, then the system may run very slow, and in some cases, it may crash and reboot. So to avoid that kind of thing, we maintain swap concept. I'll explain you what exactly swap is. Before I can explain you what is swap, let me finish talking about what would be the size of swap that will be maintained. So basically, swap is a partition that we create in our hard disk to support RAM. So what size of the partition should be to support the RAM? Swap is directly proportional to RAM. Whatever size the RAM is, according to that, we have to create a swap. So if your RAM is around 4 GB, then minimum 2 GB swap is to be maintained. If your RAM is between 4 to 16 GB, minimum 4 GB swap has to be maintained. If your RAM is between 16 to 64 GB, minimum 8 GB swap has to be maintained. If your RAM is 64 to 256 GB, minimum 16 GB swap has to be maintained. If your RAM is between 256 to 512 GB, minimum 32 GB swap has to be maintained. Same way, if your RAM is up to 1 TB, at least 64 GB swap has to be maintained. Normally, people will go twice of RAM. Suppose if your RAM is less, maybe it is just 2 GB, 4 GB, 8 GB, then you'll see people will go twice of RAM, double the size of RAM. They'll go for 4 GB, 8 GB, or 16 GB. But when your RAM is very big, then we'll go for recommended swap space. Anyway, let's move on to the next thing and let's understand that what exactly swap does. As I told you, that you are having a RAM. Let us say the size of the RAM is 1 GB, 1024 MB, for example. Now, in this 1024 MB, let us say 1000 MB is already utilized by different set of processes. So there are many processes which are sitting inside the RAM, and it occupied around 1000 MB of capacity. Out of 1024 MB, if 1000 MB is gone, how much you are left with? We are left with just 24 MB, right? So you are having only 24 MB RAM space available. Now, in this situation, you are planning to start a new process. Now, this new process can be anything. It can be the script you are running. It can be the application you are starting. It can be a browser you are opening. It can be a video player you are opening, whatever. So you are just trying to run a new process, and this new process requires at least 40 MB of RAM. Now you are having only 24 MB and your process requires 40 MB of capacity. Now availability is 24, requirement is 40. Do you think in this case your RAM can take up this new process or that new process can be started? Definitely not. Even if you try your hardest, the whole RAM will get filled up, and then to free the RAM, kernel panic will start and it will crash your system. See, if you're working on your personal laptop and desktop, if it crashes, it may not be a big problem. But just imagine on production environment, if the system suddenly crashes, then it is very, very bad and it's not a great situation. Customers are not going to like that. So how can we avoid this situation? Just think one thing. Do you think in the RAM all the time all the processes will be active? Definitely not. There might be many, many processes that might not be active. They're just waiting. Maybe you started an application and you left it behind. You're not using it. So your application will go into standby mode. So there might be many processes that would be standby, sitting idle, not in use. Now, when you have a processes which is standby, not in use, why to keep them inside RAM and engage it? They are waiting, isn't it? So can't they wait at some other place? Yes. So that place where all your inactive processes can be waiting is nothing but your swap space. So in your hard disk, you create a special partition to move the inactive processes where they can wait. Now let me tell you one thing. The processes which comes to swap will be in inactive mode. No process can be executed in swap. Swap is not a substitute to RAM. It's just a support to RAM. How? It supports the RAM by taking inactive processes. That's it. No process can really be executed inside swap space. Okay, so it's just a support. Assume there is an interview going on. Now all candidates who came for attending interview will not be sent directly into interviewer's room. There will be a waiting area, waiting hall, in which they will be waiting. So that is same like swap. If RAM is too much busy, all inactive processes will be moved out to swap so that RAM can be free and it can be used by only active processes, and the performance of your system should be maintained nicely. Now, whenever a process goes out of the RAM, we call this thing as swap out. And whenever the process comes back to the RAM, again, if it wants to get executed or activated, it needs to come back to RAM. So whenever the process goes out, we call it as swap out. And whenever it comes back to the RAM, we call it as swap in. At the time of execution, at the time of execution, at the time of execution, it is going to be very, very important. We need to check it out that how much swap in and swap out activities are going on. Too high swap in and swap out activities are not good for the health of the system, right? So if there are too high swap in and swap out activities going on, then we need to check whether swap is enough or not. If swap is not enough, try expanding swap. You have already expanded swap, but still it did not help the condition. Then we need to finally go for upgrading RAM, because you remember swap is not the substitute to RAM. It cannot take place of RAM. If expanding swap is also not helping you, then you need to expand RAM finally. But in most of the cases, the load will be spiking. Sometimes it will be high, sometimes it will be low. So it can be easily managed with the help of swap. But always swap in, swap out is not good. So in that case, you must go for this particular concept. All right. Now, let me show you that how we can work with swap spaces in a Linux machine. So in my case, I took a Red Hat Linux machine or CentOS machine in which I wanted to show you how to work. Almost the concept of swap is same in every Linux. So in order to check the status of swap and RAM, you can go for free command. When you run free command, it shows you what is the memory, what is the swap, and its usage. But this is showing in KB. If you want to view the same thing in MB, then you have to go with free-m. It is going to show you the output in megabytes. But if you want to view it in gigabytes, then you have to go with free-g. But best of all, my favorite is free-h, which shows you the output in human readable format. So it is displaying about memory and swap, how much memory you have, how much is used, how much is free. Now, what is shade? Sometimes two processes access the same area of memory, which is called as shade memory. And to boost the performance of your system, sometimes some amount of RAM is reserved for buffer or cache, right? So total available is 3 gigs. Actual available is 2.7 gigs. 2.7 plus 522 is total available space. So real free space is 2.7 only. This we have to concentrate. And you see the swap, it says 4 GB swap is there. Nothing is used. Entire 4 GB is free. Now, assume that there is a situation where your swap is completely filled up. One more thing, if you want to see the details about swap, then you can go for one more concept that is called as swap on hyphen s. When you run swap on hyphen s, it is going to show you the usage of your swap. So it is going to tell you that the name is SDA3, the type is partition, size is this much, and priority is -2. All swap will have negative priority, -2, -3, -4, like that. Now, one more time, if I run free-h, you see the memory is 3 gigs, swap is 4 gigs. So almost they are similar, there's no problem, but memory is utilized and swap is completely free. Perfect. But there might be a situation where swap is getting filled up. If the swap is close to filled up, what you will do? See, in this case, you need to expand the swap. See, first immediate thing what we can do is expanding swap. Now, if you see swap on hyphen s, it says SDA3 partition is working as swap. Now, the problem is expanding the size of the partition has some limitation. So let's say expanding the size of partition, let's assume that expanding the size of partition is not possible. So what you can do if you want to expand the swap? Now the situation is swap is getting filled up and you need to expand the swap. So the only thing what you can do is check in your hard disk, do you have space remaining or not? So you see I have 4 partitions, out of which the fourth partition is extended. So I hope you know that there are 3 primary partition, one extended, and inside it there will be logical partitions. Parted-L can tell you. So we have 5 partitions, out of which 3 are primary, one is extended, and one is logical. So logical is actually created inside extended. So if you run again fdisk-L, you see that total capacity in extended is 4 GB, utilized is 500. That means still 3.5 MB is free. So what I need to do is I need to go into fdisk, create one more partition and use it as a swap. I hope you know how to create partitions. If not, then you can go with our other videos to understand this concept well. So I'll go to fdisk and I'll go into dev SDA hard disk. Inside it, I'm going to print the partition table to view the output of the partitioning. We'll say N to create a new partition and we'll match the sector. As you see, the value on left hand side is matching with right hand side, so nothing has to be done, just hit enter. What size of swap you want to add? Partition. So I'm going to say add maybe 1 GB, or you can go with 10 GB, 50 GB as per your requirement. Print the table and see SDA6 partition has been added successfully. Now This partition has been created as a normal regular partition. Are we going to use this partition for a normal regular purpose? Definitely not. We are planning to use it for swap partition. So what to be done? You need to change the type of the partition from a normal Linux to Linux swap so that it can be used as swap. To change the type of the partition, we need to type T. It asks which partition you are changing. I'll say sixth. Now, what should be the code of the partition? See, if you don't know the code number, you can type L, small l or capital L. When you hit enter, over here you can see that the code is 82 for Linux swap. So just type that number 82 to make it compatible with Linux swap. If you don't do that, then it won't work perfectly as a swap and we might have some problems. So to avoid that, it is always recommended that you change the type of the partition to what you're planning to use. So in our case, I have changed it successfully to swap. Now let me save and quit. To come out of fdisk utility, we'll type W that will save the changes and exist. Now, if you run fdisk-l, you see your sixth partition is added and it is going to work as swap. Now, so far, it is just an empty partition. Suppose you wanted to format it with swap. So you need to use a command mkswap and the partition name. When you run that command, it format the partition with swap file system that can hold processes inside it. Now, if I run mkswap on the partition dev sta6, what we have created recently. So you see it says the size is 1024 MB and the UUID that can be used in FSTab is also created. Fantastic. Now the partition is created. What's the next step to do? See, if it is a normal partition, you will format it and then you will mount and unmount. But in swap, we don't call it as mount or unmount. We call it as activating the swap or deactivating the swap. To use a swap, activate it. To not use the swap, deactivate it. How can I activate and deactivate the swap? You have to go with swap on and swap off, right? So what I'm going to do now, I'll simply come back and first I'll check free-h and swap on-s. So you see still the swap is 4 GB and only SDA3 is being utilized as your swap partition, right? Now I'll activate it. To activate it, I'll say swap on /dev SDA3. Now, oh, I'm so sorry, it is SDA6. It's already active. 3. Now, if I go with free-h, you see the capacity earlier was 4 GB, which is now grown to 5 GB. Go with swap on-s, and you see SDA6 is also added, and the priority is -3. First -2 fellow will filled up, then -3 fellow will get filled up. Fantastic. If you want to deactivate it, then you have to go with swap off /dev SDA6. Check back the free status and swap on status. You'll see the capacity is back to 4 GB and only SDA3 is being utilized as a swap partition. Now, if you want to activate swap as a permanent thing, see, if I activate it now by using swap on, it is not guaranteed that after reboot again it will get activated. Now it will be activated and after reboot it will get deactivated. So every time the system restart, I don't want to manually activate the swap. I want the swap to get automatically activated during the boot. So in order to do that, you have to go with fdisk utility. First of all, I'm going to find what is the unique user ID of this partition. So let me copy this ID. You know how to copy the IDs on Putty? On Putty, if you just select it, it will get copied. And to paste it, you have to do right click and it get pasted out. Anyway, now I'll go to etc fs tab. To open the fs tab in VI editor, I'll press Shift G to go to the last line. Then I'll open a new line over here. I'll say O and let me paste it. Then second field, I hope you're aware that FS tab have 6 fields. Field number 1, the ID, name of the partition. Field number 2, you have to give mount point. See, for the special partitions who don't have a mount point, like swap, you can type either swap as a mount point, or the best way you can type is none. None means there is no mount point for it. Then what type of file system have you used here? I have used swap file system. What is the mount options you want to give? I want to give defaults. No dumping, no FSCK. Again, if you are not aware of these 6 fields of FS tab, please do visit our page and find out the video related to partitioning to understand more about it. Now let me save and quit. All the entries have been added. Now it's time to test whether the entry is working fine or not. As of now, if I say free-h, it still says 4 GB. If I go with swap on-s, it still says that only SDA3 is active and used as a swap. To test automatic activation of swap, you can use a command swap on-a. When you run swap on-a, it will go to FS tab. In FS tab, it will find out all the entries that are related to swap. All entries of swap will get activated. Now let me hit enter, go back with free-h. Automatically, earlier it was 4 GB, now it is showing 5 GB. Why? Because last time only SDA3 was only partition that was active, and here you see the partition that is active is 5 GB. So this is the way you can create a swap, or you can add more swap to take the overall load. Now the load of swap will be shared between SDA3 and SDA6. Both are going to work out and they are going to share the load, right? That's how the swap will be working. And it's very critical. If you don't pay attention and the whole RAM and swap is filled up, then your system may crash, and that's not good for the production environment. Finally, if you want to remove the swap what you have added, maybe I have added an extra swap which is not needed. So if you want to get rid of it, step number 1, you must deactivate the swap. So I'll say swap off /dev SDA6. Now you run swap on command. There is no SDA6. Run free-h, it's back to 4 GB. Step number 2, which you should never ever forget, go to etc fs tab and delete the entry related to swap what you have added. What happens if I don't remove that entry? At next boot, the system will try to find that partition with this ID. As the partition is deleted, ID is not found. There is a huge chance that at next boot the system may hang at one place and it would ask you to go into emergency mode to fix it. Not to have unnecessary boot issues, it is better to get rid of the IDs or the entries which is not in use in FS tab. So whenever you are planning to delete a partition, do not forget to remove associated ID from FS tab. So let me delete that line DD. Let's save and quit. Now, as you have removed or deactivated the swap partition and removed the entry from FS tab, you can now go to fdisk and delete the partition. To delete the partition, you can say D, the partition number 6, print the table, and yes, it is deleted. Type W to save and quit. That's it. This is all about your swap partition. I hope you have learned a very interesting and a very important point today, and many important concepts related to swap might have cleared. Do come back to Gotham IT's page to learn more and more important topics like that. Thank you very much to visit Gotham IT. Have a nice day.